Alright, welcome to the NUPOC video study guide number 48. We're going to skip ahead one question from the last video to question 3 in the differential equation section of guide 1. And if you're following along, you'll notice that question 2, it's asking us to find the Laplace transform of a certain function. And I think that's not exactly sure what that has to do with differential equations, and I think that's probably better suited maybe for the electrical engineering section or something, or maybe with the integration section, since it does involve that. So I'll do that some other time. But let's go ahead and take a look at this differential equation right here, right? So it's kind of similar to the one that we just did in video 47, but here we have a sinusoidal forcing function. So the function that we assume our cap y, right, is going to be a little bit different, right? In this, I think I alluded to in the last video what we're going to choose. It's going to be a little bit different than what we chose in the last video. So here, you know, y is a function of x, right? So that's why we have this forcing function as a function of x here, even though we've got y's over here. So let's go ahead and get started. Same method as last time. So let's just go ahead and assume our y of x, right? Let's assume that's some constant e to the mt, right? Okay, so our y prime is mc e to the mt, and our y double prime is m squared c e to the mt. This is running out of ink, so I'm just gonna switch pens here for a second. Hopefully this isn't really like a gel thing or like a marker one like that, so hopefully this will still be clear enough. Anyways, so we put these in here, and what we're going to end up with is, I'm not going to go through the whole thing with canceling like we did last time, but we'll end up with m squared, right, plus 4m, right, plus 3. And again, we're subbing this into the homogeneous form of this equation. This is again a second order linear non-homogeneous, right? So we're going to sub it into for the homogeneous form where the forcing function is 0, right? So this is 0 here. So if we solve for m, right, we're going to, again, you know, we can kind of do this by inspection here. So you know, what two numbers multiply to plus 3 and add to plus 4, right? So it's pretty simple. I'm thinking 1 and 3, right? And we're going to do that. So that means our two values of m that will make this function or this equation true will be m equals minus 1, m equals minus 3. So we know that our general form of the solution, I'll call it y sub g, a lot of people call it y sub c, whatever, it's just a convention, just a nomenclature of x, right? Excuse me, by the way, we're in a function in terms of x here, so this doesn't make a lot of sense to put that in terms of t, does it? No, it doesn't. These should all be c e to the mx, right? Okay. So our yg of x, right, is going to equal c1 e to the minus 1t, or just e to the minus t, plus c2 e to the minus 3t, right? Very good. So now let's go ahead and find the particular solution. Finding the solution to the non-homogeneous equation. So again, since we have a sinusoid here, let's assume that again, I'll put down, this is the general solution over here, and here we're going to start the particular, gotta sound it out, right, solution. Okay, so over here let's assume cap y, right, equals a sinusoidal function instead of exponential. So I'm going to make it, let's assume that it's a sine of x plus b, right, cosine of x. So when we do that, our cap y prime is going to be a cosine of x, right, minus b sine of x. and our cap y double prime is going to equal minus a sine of x minus b cosine of x, right? So when we sub this back into this equation, back up into our original equation here, we're going to get something kind of lengthy here. I have this written down in my notes from when I did this problem myself, so forgive me if I'm taking a little bit of time transcribing it over here. But what we're going to end up with, again, subbing these cap y terms into this original differential equation here for our y's, right? So cap y double prime goes in for y double prime. We set everything equal to sine of x. So we end up with minus, right, this y double prime minus a sine x minus b cosine x, right, plus 4 times this, right, a cosine x minus b sine x, right, plus 3 times this, a sine x plus b cosine x equals sine of x. Okay, so now when we simplify all of this down, we're going to collect our sine and cosine terms, right? So we're going to collect all our a's and b's that are coefficients on cosine, and all of our a's and b's that are coefficients on sine. So what we're going to end up with is minus a minus 4b plus 3a times sine of x, right, plus minus b plus 4a plus 3b cosine of x equals 1 sine of x, right? That's another way to write this up here, plus 0 cosine of x, right? So now we can compare terms. So everything on this sine term must be equal on both sides of the equality, right? So 1 equals all this jazz, right? So we have two equations here then. We have what is 2a minus 4b equals 1, right? And we have over here, right, we have 2b plus 4a equals 0, right? So what we do is we solve both of these equations, and I'm not going to go through it because I think this video is getting a little bit long, but just solve these two simultaneous differential equations, or sorry, two simultaneous algebraic equations, and you end up with, let's see here, you end up with a equals 1/10, and b equals minus 1/5. So you take these, a and b, you put them into your particular solution here, and so we have, let's see again, is that still visible? It is, all right. So we have y of x, right, is equal to, let's see, yg of x plus cap y of x equals this initial solution here, the general form, so it's c1e to the minus t plus c2 e to the minus 3t plus a is 1/10 sine of x, and then b is minus 1/5, so minus 1/5 cosine of x. So there we go. Again, hopefully that was clear enough with that other pen I had to pick up there. It's not a marker, felt tip kind of thing, just a ballpoint. But so that's it. And I do believe it does jive with the solution if you're following along. So that's just a good walkthrough, second order, linear, non-homogeneous differential equation, but this time with a sinusoidal excitation instead of an exponential excitation.